over 20 research papers in indexed journals, and he has actively participated in many international conferences and national conferences. We are happy to have Dr. Fajrul Karim to be here to deliver the invited talk. Welcome you, sir. Now the session is yours, sir. Kindly take over the session.
Thank you. Assalamu alaikum. Good morning to one and all present here. First of all, I sincerely thanks to this conference organizing secretary and all other team members, and also a sincere thanks to share my view for this conference. Can I share my screen?
Yes, sir.
Yes, please, sir.
Yes, sir.
What about MF? Okay. Good. One minute. Sir, are you seeing my screen?
Yes, sir.
Yes, sir.
What about time duration browser?
You can present up to 130, sir.
Okay. My voice is audible?
Yes, sir.
Yes, thank you. Once again, welcome for all the participants and organizing secretary and all other team members for New Research Innovation Society, Chennai, India. Today we have a meeting for the session. The title of the talk, The Mathematics of Cancer. This is a great time to honor few people before going to the technical session. As you know, the team members, they are given the introduction to me. And I want to appreciate or I want to recognize my memories from my supervisor, Dr. Sheikhuddin from Chennai, and my advisor, Dr. Sadaqatullah from Dubai, and my mentor, Dr. Jagir Hussain from Jamal Muhammad College, Trichy. Because of this intellectual, I will be here. I want to share something few about this. Before going to the technical session, I want to tell about the two quotes from the intellectuals. Usually when we talk about the mathematical model, we want to use the mathematical model for various purposes. The George Marx is a very intellectual mathematician. He say about all models are wrong, but some models are useful. When we construct the mathematical model, we cannot expect everything it should be useful, but something it is useful for more. That's he want to mention. And then another one quote given by the Max Gunberger. When we do the computational research are believed by no one except the person who wrote the code. Usually, the experimental results are believed by everyone except for the person who ran the experiment. These are the two opposite direction observations. Here I want to tell about to the participants and researchers, everyone. Here today I present something. This is not everything finding by me. This is the collection of information by the various people, those who are working in this interested field. To my level of best, I'm explaining, and I don't want to boring to anyone. Make it short and sweet. I will finish this session. So using these two code words, I get into the technical part. In this field, we are using the two words. One is called tumor, another one is called cancer. There are two different words are there. You are familiar about these two words from the various area. Please understand that if there is an extra normal growth in our human body or any animals, anything else, that extra normal body, it is called as tumor. All tumor need not be a cancer. The cancer, that means after the extra normal growth, the cell will be muted fraction of time, it will be become as a million, trillion times. Then it is called as cancer. What we do usually, if we have extra normal growth, if there is a pain, then we go for the treatment. If there is no pain, we don't go for the treatment. But medical science says, if you have any extra normal growth, if there is no pain, then you can take in much more carefully. It may be a cancer. So the ordinary extra normal growth, it can be called as a tumor. That ordinary extra normal growth, the cell mutation started, then it will become a cancer. So frequently we may use this session, there are two words, either is a tumor or cancer. Most probably we may use the word tumor. That tumor means we should understand that maybe the extra normal growth and the cell is muted or not. We cannot sure about it. It may be muted. So we may use frequently only the word for tumor. We should understand in simple words, tumor is the basic thing, cancer is a advanced thing, advanced one. Here, this is the purely medical science. The question will come, what is the role for math in the cancer? There is a direct relationship between the math and cancer, math or tumor. As we all mathematicians, we know about the differential equation. I think from the 12th standard onwards, we may study about the differential equation. There are two parts. One is left-hand side, another one is right-hand side. If it is the right-hand side is 0, then we may write the auxiliary equation. As you know, if suppose second order differential equation, we have the auxiliary equation. And then there are three type of roots it will come. The roots are equal, unequal, like that, as you know, all the possibilities. Based on the right-hand side, we may write the particular integral. The right-hand side may be the exponential function or trigonometrical or algebraic or combination of anything. Then finally, we wrote the solution y is equal to complementary function plus particular integral. If we have the initial condition, we apply the initial condition, then we get the answer for that constant also. As you know, all the mathematical people. The same differential equation we may use here. As you know, what is the peculiar case for the tumor? The tumor we cannot fix as a general one. If, for example, I can take a 2%, the 2% both are the same age, same sex, same condition, but the tumor will act differently. So it is a typical situation is to construct the model and evaluate the model is very difficult. Most of the time they will use the differential equation in this area, but we cannot say about the number of variables which involve it. And also we cannot say about that differential equation may be a linear, it may be a non-linear differential equation. And also system of equation it will come. If the nonlinear differential equation and the system it will come in, then we want to deal with very carefulness. Each variable is act as different way. So there is
Professor,
yes.
Professor, slide not moving, Professor.
Yeah, I will not move. I stop
Okay.
here. Okay, one by one it will come. Yeah. One by one. I'm talking about only this point only. Okay. So you should understand that directly the differential equation which involved here, we may not sure. It may be the ordinary or partial or mixing or fractional. Many things are there in this. So can we ask the next question? Can you math cure the cancer? From this part, I cannot say assuredly this is the fight between mathematics and cancer. The fight is going on. We are not sure about it, but somehow we successfully fighting against the cancer. As you know, the cancer is a very big challenge nowadays. So we may not sure about can math cure the cancer. It is not a true or false question. We may not say true or false. It is a fighting. It's a lengthy process. It is a continuous process. It is going on. The next question it will come, the medical world accept this research in the current area. Yes, obviously they accept. As you know, the medical area, they want the realistic data with the real applications. The mathematical people, the intellectual people, they given the contribution to this area, they will accept somehow. But they want to do more and more. Then the medical will, if you accept, then what is the output? Already I told about the fight between the mathematical people and the real-time problem for the evaluation of the cancer. What we do in this area, There is a problem if there is an extra normal growth. We find as a one mathematical model. Using the model, we try to find the growth of the tumor. If you find the growth of the tumor, then we go for the treatment. In what type of the treatment we select, we can give the suggestion. In this work, we given the small suggestion. We little bit identify the results effectively, but not too much. Very little bit. Because as we know, as a mathematical people, we are doing the theoretical part. The theoretical part can be connected to the real world. Means it is a problem. It will come. The error analysis, many things it will come. So medical field is accept this research somehow. Next question will come, how as a mathematician connected to this field? My simple observation, if you are very strong in the differential equation and if you know about the environment of the differential equation, then you are easy to involve in this area, easy to understand this area. Any simple way to learn in this field? That is the next question will come. Yes, it is obviously it is easy. Nowadays there are so many open sources are there, so many materials are there, so many journals are there, so many everything in the open source. Without paying, you can get it. The only one problem for the time. We spend the time, then only we can learn. Without spending the time, we cannot learn anything, as you know very clear. So with this introduction, I go to the next one. And then, as you know, this is a purely medical science. Here, this is a multidisciplinary research. I want to say about the participant one simple information. What is that? Usually, when we face this question in our classes, when we thought about the engineering math students, as you know, engineering math 1, 2, differential transformation, many things we teach. The students are asking the frequently question, where it can be applied, where it can be applied. That question it will come. Usually, my teachers are also saying the same statement. Math it can be applied for the intellectual people in the proper way. Here we want to talk about there are three parts. One is mathematics, another one is biology, that is a tumor. Third one is chaos. There are three more fields are involving here. It is purely interdisciplinary research. Can I go to the next one for this introduction? As you see, when we come for the research, usually we talk about the publication. Especially here, I want to talk about the publication based on the mathematicals of cancer. It is the exponential rate according to the PubMed records. The PubMed record means for US-based records, the number of publication it is increasingly in exponential rate. And as you know, as a researcher, if you publish more number of papers, not only the paper, it is a effective results also it will come. Then it will go to the proper reaching. So not only the number of publication, it is a effective research needed in the tumor or cancer modeling. I want to say some of the words here, the traveling path in this field. Usually we will start with the mathematical biology. As you know here, there are two different fields. One is mathematics, another one is biology. Both are mixing. The next one, the cancer research. You want to know about the cancer environment, what it means, what it is there, everything we want to learn from the cancer research. Then we want to talk about the cell cancer research, the next level. As you know the environment, then we want to go into the inner area, it will become a cell cancer research. Then it will become as a clinical cancer research, the next part, next level. Then it is a cancer discovery. We want to know what is happening in the history, we want to project to the next level, everything we want to know. Then scientific reports, then ongoing research. This is the route map in this field, mathematical biology route map, starting with the mathematics, finally they are standing in the research. Then also we want to give the future direction, what it goes. As you know, as a researcher, when you present your YOYC, for example, in doctorate YOYC, the examiner may ask the one simple question, what is your contribution in this area? That we want to identify properly, then we given the proper future direction. Some of the very good journals also asking finally, what is your contribution in this area, where you find this, like that, the meaningful question will come. So I think this introduction is enough to understand this field for mixing. There are two types of approach available. One is called bottom-up approach. Bottom-up approach means simply we want to construct the mathematical model for the convenient situation. Then we want to dealing the model, we will get the proper output. This is called the bottom-up approach. And then another one, top-down driven, that already somebody creating the model, that model also we may use in the proper way with the proper meaning. Then we can get the resultant area. These are the two types. The previous one I told about the bottom, we construct the mathematical model, then we may use. And the top-down method is somebody construct the model, then we want to do the small changes with meaningful. We want to give the proper justification why we change, why not we change, everything we want to give the proper justification, then we want to use the top-driven model. Here I want to, hereafter already I told the number of publication is exponential growth based on the PubMed record. As you see this simple graph, bar graph, in 1960, how many publications are there? In 2020, how many publications are there? After 2020, now we are in 2023, the number of publications is increasingly. Not only increasingly, we need the effective results of the publications. Hereafter, I want to say some of the important logical thinking and some of the paper I want to point out to you. Somehow I want to complete at the most, at the earliest, then I given the chance to you. You may ask any question. If I know, I can answer it. If I don't know, then I can mail you to about the questions. No problem, because I'm not sure about it. I am the answerable person to all of your questions, but I receive all your questions with gently, no issue. As you know, this is the one flow chart, how to start the process, how to develop one by step process, then how to come across the final stage. There are some dotted lines also, it is there. What it means, sometimes even bypass the road. We want to go the step 1, step 2, step 3, step 4, step 5, step 6. Some of the situation we bypass due to some various situation, various conditions. This is a simple flow chart. Already I told about this field is exactly multidisciplinary research. Hereafter, I want to show you some of the papers title. This paper, those who are interested to this field, if you want to learn tumor analysis or cancer analysis, what it is going on, you should have taken these papers. If you read this paper, then you will get the full information. This is the first paper I want to refer to you. This is the theory of hybrid dynamical system and its application to biological medical system. This is a very good paper published in 2010. This paper which gives the full detail about the tumor mathematical modeling. Here I want to say one important information. There are 3 different fields are there. One is called mathematics, another one is called biology, and third one is called chaos theory. As you know about the chaos theory, in simple words, I may say chaos theory, if you take a center, if you take a circle with a center with a small radius, then within the center, within the circle, what it happened, we don't know. Something happened, always moving in and around the circle. Look like as you imagine when extra normal grows, what it happened inside the extra normal growth, we don't know. We want to analyze that part. So this paper will address that issue in three criteria. One is called for the tumor growth and analysis. Another one is called neurons and then extension. And third one is called the future direction. There are 3 parts this paper will address with a clear manner, with a proper explanation. Those who are interested to this field, you no need to search some other area. If you taken this paper, this is it's an open file. It is available. If you search by the Google search, you will get the paper without payment. Then you can download and read the paper. It will take, I think, around 17 pages are there. You will get the full information about this area with base to higher level, the starting to and higher level. Everything it is available with this paper alone. Now I want to show some other detailed information about that. Already I told there are 3 parts which involves in this area. One is mathematics, another one is biology, third one is chaos theory. Both are involved. Here you see the paper, there are 3 words available: fractals, chaos, and cancer. Do they coincide? This paper published in 1997. As you know, these are the 3 different fields. Chaos is a physics area, cancer is a biological area, fractal is a mathematical area. this paper will address all these three, they coincide or not. This paper will justify it all are coincide with meaningful. These three fields, they will be coincide with meaningful. We want to know already I told about within a closed boundary, what it happened. Here we want to know with a clear manner, with this paper will address clearly. And then as you know about the mathematical model, as you know, one-dimensional, two-dimensional, three-dimensional, multi-dimensional model are there. When we draw the ordinary simple graph, we have only two dimensions, x and y axis. Then it will take to the 3D means we want to find, we have x, y, z axis. There are three dimensions. And nowadays, you know, so many softwares are there. It will project as a multi-dimensional, it is there. Here they taken as a one three-dimensional model, how they connected with the chaos theory and the three-dimensional cancel model. That question will addressed by this paper. And then the third paper I want to highlight here, a hybrid approach to the multi-scale modeling of cancer. As you know, the word here, now when we go for the market, you use the word. If you purchase any fruit, you may ask, this is artificial or this is a hybrid or what it is. Usually we may purchase the fruits with seed. Without seed, mean that is called hybrid. Is it right? I think I may right. If you purchase any fruits, if it is there, a seed means, then we call it as a normal. There is no seed in the fruit, means that is abnormal. Is it right? That may call it as a hybrid. Here, they are dealing the word with a hybrid approach to multi-scale modeling of the cancer. The previous paper I told about, that is a three-dimensional cancer model. This is multi-scale cancering model. We want to further more information in this paper. Then I want to mention another paper, what can be learned from the chaotic cancer model. As you know, the chaos theory and connected with the cancer, the effective manner, this paper will address what we want to learn these two specific areas. Then I want to give in the next important paper, mathematical modeling of tumor growth and treatment. As you know, when I start this speech, the medical field will accept this research. As I ask the question and also I will say the answer also, it is accepted. What means accepted? We want to construct the mathematical model for a peculiar situation. Then that model can be analyzed by using the MATLAB or any other technical software. We do use that. That model will be executed by the that means biological students. For example, cancer biology. So many biological undergraduate, postgraduate students, they are doing the simple projects are there. We given the model to them, they given the data, they execute the model, then we find the result. What means the result? That result which gives the guidelines to the medical practitioner, that is called as a doctor. We want to given the guidelines. This is a very complicated area because, as you know, directly we cannot go by the human. If we have the extra normal growth, we construct the model for the extra normal growth. Then we want to analyze by using the many softwares. Then finally we get one result. That result we will given to the medical practitioner. I mean, they will never accept it because this is an offense. If the result something wrong, mean the patient may be die. So what the logical says, they first you use the model in rabbit, then you come for monkey, then you come for human. This is the pathway the medical field will accept. We may not directly act with a human. That will be offense. Then we will be in the jail if suppose something wrong in the result. So this is a lengthy process. For my research, only we traveling in the rabbit. That will go to the monkey, and the next level mean, as you know, the real-time project which involves the lakhs and lakhs of money. That is depend upon the money we may travel. So we finally, our aim to given the guidelines to the treatment for the medical practitioner, it's somehow successful. I'm not sure about it. This is 100%. My point of view, we will contribute only the 20 to 25% only, not more. Then I want to go to the next paper. This is one important paper. As you see that there are two papers here in this mathematical models of cancer, when predict to novel therapies, when not to predict. As you know, if you have very close relationship with any cancer patient, there are various methodology to cure the cancer. The elementary stage mean they will given the medicine. If it is the higher level, mean they go for the radiation. The next level, if you go for the remove the part. As you know, if the tumor growth available in our finger, then we can remove the finger. If the mutation is more, if we have the extranormal growth available in our throat, how can we remove the throat? It is not possible. Based on the position, it may remove or not remove. If it is the finger, if the mutation is more, then we remove the finger. If it is the throat, we may not be remove the throat. If there is an stomach, we cannot remove the stomach. So based on the situation, sometimes last 2 weeks or 3 weeks, I saw one person, that person having the cancer in the urinary path. In the male patient, he has the cancer growth in the urinary path. They know how to remove the urinary path from the human body. It is a very typical situation. So based on the situation, we want to do select with therapy suitable for the person and which is effectively everything, and also the cost also which involves. Here I want to mention another one paper, the mathematics of cancer, integrating quantitative model. As you see, this paper published in Nature. As you know, those who are the researchers, you know about the Nature publication. Already I told when I start the presentation, if you want to enter in this field, you learn one paper. If you want higher level details, if you taken this paper also, you can get it from the Google search without payment. You download this paper, you can get the more and more information in higher level. And especially this paper will address all kind of mathematical model. Ordinary differential equation, partial differential equation, delay differential equation, fractional derivatives, everything they are using model. They given the model. From the model, what are all the observation, what are all the direction, what are all the next step, everything they are given in this paper. I think this is my presentation. This is a time for you, questions. Can you go for the question that is better?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Thank you, sir. Thank you, sir.
Speaking a little bit fast, that's my nature.
That's fine, sir. That's fine. That's fine. Thank you, sir. Thank you, sir. The nice presentation. Thank you very much. The delegates may ask questions or clarifications.
Please feel free to ask any question. If I know the answer, can I immediately say? If I don't know answer, no problem. Because the researchers, we don't know everything. We know a little bit only.
Sir, let me ask a question, sir.
Good, sir. Go ahead.
Sir, you are talking about the quantitative models. Can these quantitative models identify whether they can identify the stage of cancer early, or they can cure the disease early? What is the direction of this research, sir?
Both it is possible. Both it is possible.
Yes.
The first point is that in the cancer, the problem is if you identify late, then it will become serious.
Okay.
If the correct time you may identify means we can go by using the medicine we may cure.
Yes.
What happened? That's why I told when I start my presentation, if you have the extra normal growth, we have pain, then we want to looking into that. There is no pain, we don't bother about it.
Yes.
But medical science says if you have extra normal growth, anything in your body, there is no pain, then you can take it more carefully. When we go to the doctor, they will check, they will taking the small sample, they will analyze what happened, it is there. If they identify mean, then they start the medical, they start the treatment. Sometimes they given the medicine, sometimes they given the radiation based on the situation, based on the case by case. Your question is, the mathematical model can address the stage. Yes, it is address the stage. It is given the treatment. We are not directly involved in the treatment. We given the suggestions only. That's why I told we cannot directly act with the human. We may start with the rabbit, then come for monkey, then come for human. If we act directly, mean it will goes wrong. Then what happened? The patient may be dying.
Yes, sir.
That's our funds.
Yes.
So all the stages are there due to the situation. In my point of view, everything it is possible. As you know, in mathematical calculation, the error, it's a very big problem. The error analysis. The error is less means it's good, but sometimes it is not. As we know, those who are running the experiment, they know the situations. The error complication is too much. So somehow we are fighting. It's a fighting is going on.
Yes, sir. Thank you, sir. Thank you, sir.
Yes, researchers, I'm waiting for you.
Any questions from others, delegates?
Can you understand what I mean?
Yes, sir. Yes, sir. Yes, sir.
Thank you.
So, Professor, very nice presentation, Professor.
Thank you. Thank you so much.
Mathematical people understood.
Because when we teach in the engineering students, we are always dealing the differential equation. Very
Yes, sir,
simple. Then that is a starting stage. Without differential equation, you may not enter in this field. If you enter with the basic differential equation, then you can come further. So many things are there. The challenging task to construct the model. If you construct properly, then you can use the software, something, it will come.
Any other questions from audience?
Okay. If there are no questions, let us thank Professor Dr. Fajlul Karim, who has come over to our conference and delivered an excellent talk. And I hope all the researchers should have enjoyed his talk. It was something innovative and different from normal presentations because it is connected with the health of human beings. Thank you, sir. Thank you very much. So
Welcome.
I thank you all the delegates. I request you all to join for the afternoon session at 2:30 p.m. with Dr. Shivani Gupta from School of Computer Science and Engineering, Vellore Institute of Technology, Chennai, who will be delivering a talk on domain of competency of classifiers. Thank you. Thank you all.
Sir,
Let us
feedback
join.
also posted, sir, in message box.
Yeah.
Send it to all.
Okay. Kindly, all participants, kindly fill the feedback and submit. Thank you all. Thank you, Professor. Thank you very much for the presentation.
Thank you.
Thanks a lot.
Thank you.
Thank you.